Hello, welcome to the Music and Computer Science slideshow by Isabella Chen and Emily Nee. So, a topic overview. Today we will be covering variables and its mutability, conditionals, and Boolean logic. So, computer science in music allows for music to become digital, though there are many examples of the works of computer science in music. Some are sound engineering, music playability, music-based games, and many more. So variables hold information, for example, x gets 2, and are mutable. There's an accounting method, and since variables can change anytime, we can use the accounting method to help keep track.
Especially in a dynamically typed language, such as Python, it's very helpful to be able to keep track through the accounting method that Isabella just mentioned. And I'll be going through a live code walkthrough now. This is the original code taken from our professor's slides, but because it was really blurry, I rewrote it here. So we first have our variable x, and we also have our variable y. We don't know what x is, right? We have enter letter blank, but we do know what y is, and that's 3. So the next thing, we're kind of seeing that it branches off into x equals a, and there's also some other, like x equals b and some other stuff. So we're gonna start by doing x is a, and y is still 3, and on the other side, there's another one where x is, as we can see, else, right, is not a, and y is still 3. And after we run that code, after we run the x equals a code, we're gonna run that y gets y plus 1. So we're just gonna add 1 to the 3, so 3 plus 1 is 4, and else y gets y minus 1. So 3 minus 1 is 2. And that is that so far. But then as we can see, after we've run kind of this entire block of code, this is the next part of it, which is y gets y plus 1. So we're going to cross out the 4 and add 1 to it. So we get 5. And here we get 2 plus 1, which is 3. So we end up with this stuff. But then we also have another option down here, which says if x is equal to b. So we can see for that, it kind of branches off of the not a segment right here. So we're just gonna draw a little thing over here. X is b, and y, it's still 3. And from here, we can see y gets y plus 10. So we're gonna cross this out, and 3 plus 10 is 13. So from here, we kind of see this like branch. It kind of starts up here, right? And then it goes here, then here, and here. So like we can visualize this, right? By doing this and kind of like that. And we can draw some leaves on here and it'll really look like a tree. And a quote from our professor is that when we have if statements, we create a tree of possible computations that might happen in the future, which is exactly what you have right here. So yeah. Okay. So next we have the Boolean logic. So all values are either true or false. And this is centered around 3 simple words known as Boolean operators, or, and not. So as you can see, the or is just when any data point present is like, it makes it true. So for example, x equals 2 and like x equals 3, if you have either one of those, the value kind of becomes true. For the and, you have to have x equals 3 and x equals 2 or 3, I forgot what I said. Both of them have to be true. And the last one, if it's not x equals 2, then it's just anything that isn't 2, x equals 2. And in the next slide, we have kind of an example showing the Boolean logic. If choice equals string s, that's just kind of what would make, like, if that's true, then it would print. And there's like a more complex example down there. Yeah, now Isabella will talk about conditionals.
Yes, conditionals. What are they? Conditional bodies are logical operations. And the most common ones are if statements, elif statements, and else statements. In an if statement, if something is true, then the code in that line will be executed. If the if statement is false, then the code jumps to the elif statement. And if the elif statement is true, then the block of code will be executed. However, if both the if and elif statements are not true, then the else statement will be executed.
How you could be so okay, that I'm gone.
Emily, did you just start playing music?
Yeah, I just did. Do you like it?
I love it. What song is that?
It's called Driver's License by Olivia Rodrigo.
Oh, can we keep playing music, like using a playlist?
Yeah, sure. I can actually skip to the next song.
Oh, how?
Yeah. We actually made a code for this, as we will be showing in the next slide.
Yes. So, Emily and I wanted to create something where we could see computer science and music come together in our day-to-day life. So we created some code that runs a playlist. We start off by listing some popular songs in a variable, which we called song, where you can see in line 2. Then we use a variable to create an input so that a user can choose their options. In this case, either S to shuffle the playlist or C to play the playlist chronologically. We further declare variables that are holding information that we will use later on in the code. Here we want S to get a random song, X equals 0, and chronological to get song X. After declaring our variables, in line 9, we create conditionals, an if statement with a while loop inside. So here, if the input is S, where you can see in line 9, a random song is printed, where you can play it. We declare another variable here, which allows an input of whether the user wants to continue playing songs, where you see in line 11. In this while loop, the user has the option to keep playing songs until they input N for no. And if they input N for no, then thanks for listening is printed.
Yes. And on the flip side of that, if elif, the choice, is equal to string C, which stands for chronological, then X is going to be set to 0 to account for how in computer science or programming, the first digit is often known as 0 instead of 1 for counting purposes. And so we're going to have chronological equals to song index X, or which is also 0. And then we're going to have that print chronological for us. And then in line 23, we're going to have a variable another, which Isabella mentioned before, and it's going to input to the user, do you want to play another song? Enter yes or no using Y or N. And while another equals yes, and X plus 1 is less than the length of song, it's going to do something. But right here where it says X plus 1, what we're doing there is we're accounting for the fact that in computer science, it starts at 0, so we want to add 1 to get to the true position in the playlist or the songs. So basically what this kind of means is that the song or the position in the playlist or songs exists. And when that happens, we're going to do X gets X plus 1. And we're also going to print song at position X. And then we're going to ask it if we want another song, enter yes or no. And then if they put no, it's going to print thanks for listening. And there's another part of this, which is that while another equals yes, and x plus 1 is greater than or equal to the length of the song, then we're going to print no more songs. You've reached the end of the playlist. And what the x plus 1 is greater than or equal to the length of song means is basically that the position that it's kind of counting at does not exist. And that's why we can't play an additional song. And then at the end of that, we're going to use the break, which stops it from repeating and constantly playing different songs. And yeah, and then the final thing in line 33 is the else statement, which prints to stop running the program and follow the instructions if the user did not input S or C the first time around, because that is what we told this machine or this algorithm to do for us. So yeah, that's it.
Thank you so much for tuning in to our presentation. We hope you enjoyed it.